Hey guys, welcome back to Click Academics. In today's video, I'm going to be teaching you guys how to solve this exponential equation. So we have x to the power of x to the power of 4 equals 64. Now, what I'm first going to do is I'm going to take the fourth power of both sides. So we're going to take the fourth power of x to the power of x to the power of 4 as well as 64. Now, an important property of exponents is that if we have a to the power of b to the power of c, this is actually equal to a to the power of b times c. So what we're going to do over here to x to the power of x to the power of 4 to the power of 4, we're going to multiply x to the power of 4 times 4, because in this case, x to the power of 4, this is b, and 4 is c. So this would equal x to the power of x to the power of 4 times 4. And this is still equal to 64 to the power of 4. Now, what I'm going to do is I'm going to switch this so that it's in the form x to the power of 4 to the power of x to the power of 4. As you can see, all I did was switch the order. Before it was x to the power of x to the power of 4 to the power of 4, and I simply switched the order of 4 and x to the power of 4, and that is completely legal. And this is still equal to 64 to the power of 4. And notice how x to the power of 4 and x to the power of 4 are the same, right? Well, I actually want to convert this equation so that it's in the form a to the power of a equals b to the power of b. Because if it is in this form, then we could just set a equal to b. So we already have x to the power of 4 to the x to the power of 4, so we already have a to the power of a. Now we just need to convert 64 to the power of 4 so that it's in the form b to the power of b. So 64, this is equal to 8 squared, right? So we're going to replace 64 over here with 8 squared. So we're going to have 8 squared to the power of 4. And we're going to use the same property, a to the power of b to the power of c equals a to the power of b times c. So 8 to the power of 2 to the power of 4, this would equal 8 to the power of 2 times 4, which is 8. And we still have x to the power of 4 to the power of x to the power of 4. Now we can say that if a to the power of a equals b to the power of v, a equals b, right? So if x to the power of 4 to the x to the power of 4 equals 8 to the power of 8, then we know that x to the power of 4 equals 8. Now we want to cancel this fourth power here, so we're going to take the root of 4 on both sides. Now these two would cancel out, so on our left side we would have x, and our right side we would have equals positive or negative, remember it's plus or minus, the fourth root of 8. And this is our answer. Hey guys, welcome back to Click Academics. In today's video, I'm going to be teaching you guys how to solve this exponential equation. So we have 10 to the power of 3 minus x equals 1. So whenever we're solving exponential equations similar to this one, we always want to make sure that our bases here, in this case 10 and 1, we want to make them the same. Because let's just say I have a to the power of x, and this is equal to a to the power of y. Well, we know that these two terms are equal to each other or the same, and we can see that both of them have a base of a. Well, in this case, doesn't that mean that their exponents are the same as well? Because if they're different, then that means this would be wrong. They can't be different because their base is already the same, meaning their exponents have to be the same as well. So in this case, if we were to change the bases so that they're the same, then we would know that the exponents are the same as well, so we could just set the exponents equal to each other and solve for x. So we want to make the bases of 10 and 1 equal each other. Well, that means that we have to change one of the bases. And we can't really change 10 to be equal to 1, so why don't we change 1? Well, 10 to the power of what equals 1? 0, right? Because anything to the power of 0 actually equals 1. So we should change 1 to 10 to the power of 0. And this still equals 10 to the power of 3 minus x. Now notice how these two bases are the same, just like this one. And think of 3 minus x as x and the 0 as y. Because these two bases are the same, then that means that these two exponents are the same as well. So we can just ignore the bases for now and just set 3 minus x equal to 0. And now, as you can see, we've created a simple equation using our method. So now, to get the value of x, we're going to have to make it go to the right side. So we're going to add x on both sides. And these two cancel out, so we're left with 3 equals 0 plus x is x. So now we have our value for x. Now, why don't we go ahead and plug it in to our equation? So this gives us 10 to the power of 3 minus 3 equals x. So 3 equals 1. 10 to the power of 3 minus 3 is 0. Equals 1, and remember, anything to the power of 0 equals 1, so 10 to the power of 0 equals 1, so we have 1 equals 1, and this is right, meaning our answer of x equals 3 is right.